Australian Mathematics Curriculum, Tree Diagrams for Independent Events. We're going to start this one with an example. A coin is tossed and this four-sided die numbered 1 to 4 is rolled. List the sample space. To do this, the easiest way is to set up a tree diagram. We start by tossing the coin. Our options are either we'll get heads or we could get tails. After that, we've got the die. There's 4 different options for the die. Now, if I were to roll heads on the coin, what are my options for the die? Well, I could get 1, 2, 3, or 4. If I rolled tails on the coin, what are my options for the die? Again, I could get 1, 2, 3, or 4. If we follow each line along, we get the outcomes, and the list of possible outcomes is the sample space. So I could get heads on the coin, 1 on the die. Oh, doesn't look like a 1. I could get heads on the coin and 2, heads and 3, heads and 4. Or I could get tails and 1, tails and 2, tails and 3, tails and 4. Excuse my 4 there. That's the sample space. So when we go to answer the question, let's go back up. The sample space gets put in those little curly brackets, and it's all those outcomes that we just found on the tree diagram. Separated by commas. Sorry, I'm getting a little very messy there. Tails and 1, tails and 2, tails and 3, tails and 4. Our sample space, preferably fit on one line. Each one of those outcomes, there's 8 different possible outcomes in that question. If I was asked to find probability, for example, what was the probability that I roll heads? Let's have a look back at that. These 4 outcomes include rolling or tossing a coin and getting heads as my result. So my fraction would be 4 possibilities out of the total of 8, which is a half. And we can see that definitely the probability of getting heads when we toss the coin is totally separate to what happens on the die, and that's just a 50% chance. What if we were asked the probability of getting tails and an odd number? Let's go back and look at this. Well, all the probabilities with tails would satisfy that, or we could have an odd number, which would be these 2. A total of 6 different outcomes that would satisfy the question, what if we got... Oh no, it wouldn't. I just did tails or odd. That's embarrassing. Let's go back. We're looking for tails and an odd number. Totally a different question. I've got to get tails and odd. That's got tails and an odd number. That's got tails and an odd number. 2 of them only. So the probability of getting tails and an odd number is 2 out of 8, or 1 over 4. Because we simplify the fraction, 2 goes evenly into 2 and 8. 2 divided by 2 is 1. 8 divided by 2 is 4. Our fraction's simplified. Now we've got this question which I was answering before. Tails or an odd number. Very different question. Let's look at our outcomes, which are getting a little bit messy. Tails or an odd number says tails is fine, so all the tails are fine, or anything that gives me an odd number. Almost circled an even one there. So this has got an odd number, this has got an odd number, and these all have tails. So tails or an odd number says I'm quite happy with those. What did I have? 6 outcomes out of 8, which simplifies. 2 goes into both of them, 3/4. So the difference between and or is very important in these questions. Let's have a look at another question. Stephen tosses a coin and spins the spinner. Question 1, draw a tree diagram to list the possible outcomes. First thing that happens is I toss the coin. We know the possibilities for that. I could have heads or tails. After getting heads or tails, we spin the spinner. There were 3 different choices on the spinner. Let's just check what they were. Red, yellow, or blue. So our options there are red, yellow, or blue. We follow along from tails as well, because if we got tails when we tossed the coins, we've still got 3 possibilities for our spinner. Again, red, yellow, or blue. And we follow these along, and we can find our possible outcomes. I could get heads and red, heads and yellow, heads and blue, tails and red, tails and yellow, tails and blue. And if they asked for the sample space, that's the sample space because it's all the possible outcomes. You can see that each one of these gives us an outcome, so this tells us that I've got 6 different outcomes. I've drawn a tree diagram and listed the possible outcomes. Find the probability that it's a head and it's blue. Well, the only thing that satisfies that is heads and blue. We're not asking or, we want and. One probability only. So that's 1 out of a total possibilities of 6. The next question wants to know what happens, what's the probability of getting tails or red. This is or, so any of the ones that have tails is fine, and also any of the ones that have red is fine. Of course, we don't count this one twice. That's 4 totals, possibilities of tails or red, out of our 6 possibilities. Simplify the fraction, that's 2/3. Now, when we do a tree diagram, we're allowed to write the probabilities on every branch. Looking at this tree diagram, the probability when I toss coin 1, probability of getting heads is 1/2. Probability of getting tails is 1/2. No matter what happened for coin 1, coin 2's probabilities remain the same. It's still 1/2 for each one. We can still read across and get the outcomes: 2 heads, heads and tail, tail and heads, or tail and tail. Now you can see there's actually 4 different outcomes in that. The probability of getting heads and heads is 1/4. This is useful to know when you're playing that game called heads or tails. We can actually work out the probability mathematically by multiplying the probabilities along the line. The probability of getting 2 heads is 1/2 times 1/2. 1 times 1 is 1, 2 times 2 is 4, it's 1/4. And we can see that that was the case anyway. We have a sample space of 4 outcomes, and 1 out of 4 gives us the answer. It's getting a bit messy in here. Let's remove a few of those. In the same way, I can work out that tails and tails is a half times a half, which is a quarter. If I wanted to know what the probability is of getting two different coins, there's two ways of getting that out of 4. So we could predict that it's going to be 2 over 4 or a half. But we could also multiply a half times a half that way and a half times a half that way. This one's, a half times a half is a quarter. This one's a half times a half is a quarter. But both of those will give me the result I want, 2 different coins, and so I've got a quarter plus a quarter would give me a half probability, since both of those will work.